Hi everyone. I wanted to make a video to show you one more type of practice problem that you might see with solubility equilibrium. So this is what we call selective precipitation of ions. So knowledge about solubility in KSP can help us to separate two metal ions from each other. So let's say, for example, we've got a solution that has both silver ions and lead ions in it. And you can see here the concentration of silver is 1 times 10 to the negative 2. And the concentration of lead is 2 times 10 to the negative 2. All right, so what you can do is you can add chloride ions. So that could be like sodium chloride, potassium chloride, whatever. But anything with chloride ions, both silver chloride and lead chloride have the potential to precipitate. And you can see I've got the KSP values for both of those. So my question here is, what concentration of chloride would be necessary to begin the precipitation of each salt, and then which of those salts will precipitate first. So let's walk through how to solve a problem like this. All right, so here I've just summarized the information in the problem. So I have the potential to form silver chloride, which would dissociate into silver ions and chloride ions at equilibrium, and the potential to form lead chloride, which would dissociate into lead ions and 2 chloride ions at equilibrium. Now I've made note of the concentration of silver already in my solution and the concentration of lead already in my solution, and then the KSP values for both. So let's start with the silver chloride up here. All right, so if I know that my KSP is equal to 1.8 times 10 to the negative 10th, I also know that my KSP expression is going to be equal to my silver ion concentration times my chloride ion concentration. So my KSP expression would be the silver concentration times the chloride concentration. So what I can do here is I can plug in everything that I know. So I know my KSP. I know my silver ion concentration from the question. And if I know those two things, I can solve for X here. All right, so when I solve for X, I get that X equals 1.8 times 10 to the negative 8th molar. That means that I'm going to need a concentration of this amount of chloride ions for silver chloride to precipitate. So you can see that's not very much. I only need a tiny amount of chloride in order for silver chloride to precipitate. So again, that X is equal to my necessary chloride ion concentration in order for precipitation to occur. Now I can do the same thing with lead chloride, and then I can compare and say which one is going to precipitate first. So I'm going to set this up the same way. So I know that my KSP for lead chloride is 1.7 times 10 to the negative 5th, and that my KSP expression for lead chloride is going to be the concentration of lead times the concentration of chloride squared. And again, I'm just going to plug in what I know and then solve for my chloride ion concentration. So I've got 1.7 times 10 to the negative 5th equals 2 times 10 to the negative 2 times my chloride ion concentration squared. So again, I'm going to solve for X here. All right, so first I want to divide both sides by 2 times 10 to the negative 2. So that gives me 8.5 times 10 to the negative 4th equals X squared. And then when I take the square root of both sides, I get that X equals 0.029 molar. All right, so I would need a concentration of 0.029 molar chloride ions in order for lead chloride to precipitate. So the first question, how much chloride would I need? My answer for X is that answer for the chloride concentration. All right, so for both of these, I've got an amount. Now, as far as which one precipitates first, I want to look at whichever one requires less chloride. All right, so if I'm adding the chloride a little bit at a time, silver chloride is going to precipitate as soon as that concentration of chloride is 1.8 times 10 to the negative 8th. Right, that's a much smaller amount than 0.029, so 2.9 times 10 to the negative 2 here. All right, so whichever one requires less of your ion to precipitate is going to be the one that precipitates first. So that means silver chloride will precipitate before lead chloride. So if I was trying to separate a mixture of silver and lead, I could precipitate the silver leaving the lead in solution if I added just a very small amount of chloride. All right, so here's another practice problem for you to try. I would suggest that you pause the video, try to solve this problem, figure out which ion is going to precipitate first, and then what concentration of hydroxide is going to be necessary to begin the precipitation for each cation. All right, so I've completed this problem in the same way. So you can see first I looked at the magnesium and then the copper. So I was starting off with 0.050 molar magnesium ions. So when I set up my KSP expression, I've got my magnesium concentration times my hydroxide concentration squared. And so I'm going to plug in my KSP, plug in my magnesium concentration, and solve for X. So when I do that, I get a concentration of 1.9 times 10 to the negative fifth molar as the hydroxide concentration necessary to cause magnesium hydroxide to precipitate. For copper hydroxide, I've done the same thing. So I started off with 0.020 molar copper in solution. I set up my KSP expression. It looks very similar because both of these are +2 ions, so I need 2 hydroxides. So that value is squared. I plug in my KSP and my initial concentration of copper, and I solve for my hydroxide ion concentration, which is 1.0 times 10 to the negative 9th molar. All right, now these are my amounts of hydroxide necessary for the precipitation to occur. And then I want to look for whichever one is a smaller number to tell me which one is going to precipitate first. So in this case, my hydroxide concentration is lower for the copper hydroxide. So copper hydroxide will precipitate first.